Before its discovery even reached Earth, 3IE Atlas had already defied expectations. Spectral analysis revealed nickel where only dust should exist, metal where ice should dominate, a Manhattan-sized visitor shedding industrial-grade alloy in a region untouched by civilization. Scientists weren't startled by its arrival. They were unsettled by the evidence of deliberate manufacture. Something out there was performing metallurgy in the void, a city-sized object quietly producing metal in the empty expanse between Mars and the Sun. Astronomers initially classified it as a fast-moving interstellar object slicing efficiently through our system. Named 3IE Atlas, the third confirmed visitor from beyond the solar system, it shouldn't have behaved unusually. Comets follow predictable patterns. As heat reaches their icy cores, volatiles vaporize, producing a tail that stretches away from the Sun. This has always been the rule. Yet images from Hubble in late July revealed something unnerving. Instead of a sweeping tail, Atlas exhibited a dense, directed jet of expelled material aimed sunward, a reversal of natural expectations. This jet wasn't a faint plume. Observers calculated a mass ejection of roughly 330 pounds per second, including carbon dioxide, water, trace cyanide, and nickel, but no iron. That absence was significant. In every known comet, including prior interstellar visitors, nickel and iron appear together in roughly equivalent amounts. They condense from stellar furnaces side by side. To emit nickel without iron requires precision, selectivity, and a process beyond natural chemistry. Harvard astrophysicist Avi Loeb spoke publicly on the anomaly. He suggested the composition resembled nickel tetracarbonyl, a compound humans produce industrially for aerospace coating and surface hardening. It doesn't form naturally in comets or planetary crusts. It requires controlled environments with carbon monoxide under pressure. Its presence implied industrial-style metallurgy in deep space. While some researchers urge caution, hoping for a natural geochemical explanation, the combination of refined chemistry and directional outgassing strained conventional science. The anomaly extended beyond chemistry. Normal comet tails obey physics. Solar heating drives volatiles outward, and radiation pressure sweeps them away from the Sun. 3IE Atlas defied this, projecting its mass directly toward the Sun in a coherent, dense column. Imaging from KK2 in August confirmed nickel outgassing at roughly 4 grams per second, steady and selective. Its plume pulsed over time, narrowing and widening in rhythm, implying either rotation-synchronized emission or active regulation, a kind of gating. NASA's orbital models, while accounting for thermal effects, couldn't reconcile Atlas's deviations. Minor perturbations in its ephemeris indicated self-generated torque. In conventional cometary physics, this would be insignificant. Here it was inverted, precise, purposeful. If interpreted as engineering, it would explain both the absence of a typical dust tail and the production of high-temperature metal compounds like nickel tetracarbonyl. Under sunlight, the compound decomposes into nickel and carbon dioxide, potentially acting as reflective exhaust or radiative shielding. Every observation reinforced the same conclusion: this was not a passive object. 3IE Atlas appeared to manage its own surface, expelling and redepositing material in a self-plating process that could strengthen or regulate its outer layer. The steady brightening observed by telescopes near Mars aligned with this idea, as did the lack of conventional cometary dust tails. The emitted material, heavier and cohesive, behaved unlike natural sublimation. The implications were staggering. On Earth, nickel tetracarbonyl is handled in sealed loops for safety and precision. In the vacuum of space, sustaining the same chemistry requires internal reservoirs and cycling mechanisms. Whether through unknown natural processes or artificial design, 3IE Atlas was producing an alloy suitable for aerospace applications continuously, silently, with remarkable precision. KK's observations captured the chemical signature but offered no explanation for the object's intent. The light recorded by KK existed purely as data, flux ratios, emission lines, and timestamps from clear August nights. For the teams analyzing the numbers, the divide was clear. Some saw chemistry. Others glimpsed something far more unsettling: purposeful, precise, and unprecedented activity occurring in the heart of interstellar space. The other observers saw intention. Official reports leaned toward a natural explanation, cautiously framing the nickel emissions as potential photochemical effects within a rare carbon-rich body. That was the language of restraint, written by scientists who understood how easily a single word could spark speculation. Yet descending voices noticed the pattern, the emission. Intensity varied at near-regular intervals, hinting at rotation-linked venting. Some frames suggested the jet aligned with the solar vector, and the absence of random dispersal contradicted standard models of volatile-driven outgassing. The data behaved like a system, not a leak. KEK faced technical limitations. Its spectrographs could measure wavelength with incredible precision, but texture remained invisible. If Atlas's surface contained repeating ridges, plates, or cavities, telescopes at that distance couldn't resolve them. The light curve revealed rhythm, but not reason. Within weeks, the anomaly drew attention beyond academia. Observatories began cross-referencing KEK's nickel readings with early infrared data from the James Webb Space Telescope. Webb confirmed similar absorption features, eliminating instrument artifacts. The phenomenon was real. Its origin remained a mystery. If Atlas carried industrial-grade compounds, it challenged traditional classification. Interstellar objects are expected to be pristine archives of stellar birth, untouched for eons. Atlas behaved differently. Its chemistry suggested either natural processes unknown to science or remnants of a system where metallurgy or technology evolve in ways we do not yet comprehend. For KK researchers, the hardest challenge wasn't chemistry, it was optics and perception. Declaring an object potentially artificial invites ridicule and scrutiny. The safe path: publish the data and let others draw conclusions. They did, noting the nickel as strange, but possibly natural. Behind that caution lay frustration. The anomaly was verified, reproducible, and yet logically inexplicable. Atlas remained a mystery written in elements. KEK's images captured only the shadows it left behind. Every object entering the inner solar system faces the sun's judgment. Radiation tests composition, surface structure, and thermal resilience. Ordinary comets succumb, disintegrate, or fade. Atlas, by contrast, transformed. From July to October, telescopes recorded progressive brightening unrelated to heliocentric distance. Typically, brightness peaks near perihelion and fades during retreat. Atlas defied this, increasing its albedo even as it moved away from the sun. Analysts initially considered dust release, but spectra revealed no broad silicate signatures, no particulate haze. The reflected light intensified specifically in the near-infrared, indicative of metallic surfaces. Atlas wasn't shining due to dust, it was actively changing its skin. Nickel tetracarbonyl under solar irradiation decomposes into pure nickel, which can form a reflective coating. Continuous emission and redeposition might have plated Atlas with its own material, effectively creating a self-forged mirror. Brighter surfaces reflected heat, stabilizing the object and allowing further approach without catastrophic loss. The cycle was elegant. Heat drives out gas, gas deposits metal, metal reflects heat, and the object survives. Engineers would recognize this as passive thermal regulation. In comets, it should not exist. Trajectory adjustments hinted at control. Angular drift slowed in ways suggesting the object was balancing its own thermodynamics. No random torque from venting appeared. The spin remained remarkably stable. Natural explanations strain under such precision. Previous interstellar visitors, Oumuamua and Borisov, followed predictable thermophysical decay. Atlas defied that lineage, orbiting not as debris, but as if aware of survival. Its mirror-like surface communicated an undeniable principle: reflectivity equals endurance. Whether physics taught this or programming, its surface was no longer what it had been when it entered the solar system. The sun tried to burn it. Instead, it polished itself. When direct measurements become politically or logistically inaccessible, light remains the medium no agency can fully contain. Each photon carries a fingerprint of origin, readable by telescopes worldwide. Since KK and Webb's findings, observatories from Chile to the Canary Islands have dissected Atlas's spectral heartbeat. Minute fluctuations in brightness are monitored independently, probing whether the glimmer is chaotic or deliberate. Photometric records reveal rhythmic spikes recurring roughly every 9 hours, possibly linked to rotation, but also suggesting symmetric surface regulation. Ordinary comets tumble unpredictably. Their light curves appear erratic. Atlas is metronomic. The steadiness implies equilibrium, not collapse. If self-plating nickel explains the reflectivity, Atlas effectively functions as an engineered mirror. Each pulse of sunlight returns a measured flash, creating data. Planetary defense models account for increased radiation pressure from reflective surfaces, projecting cumulative displacements over future orbits. The shift isn't threatening, but it proves interaction with light is deliberate, efficient, and measurable. Scientists call it albedo variation. Engineers see signal regularity. The distinction is uncomfortable. Coincidence or intent matters little. Physics itself remains unbound. A body from beyond the solar system is using sunlight in a way unseen before. If natural, it teaches. If intelligent, it waits. In either case, the lesson is written in faint photons, visible only to those willing to measure. Observing Atlas tests the limits of human reasoning. Every flicker, every pulse is both evidence and challenge.